Welcome to AI for Specialists. Today we're diving deep, really getting into how artificial intelligence is, well, fundamentally changing custom electronics design. We're talking specifically about printed circuit boards, PCBs. Now think about the old way of designing a complex PCB. It's always struck me as this incredibly detailed, almost like a high-stakes manual chess game. I just loaded with potential problems, right? Can you maybe paint a picture for us? Just how tough was that traditional workflow?
Yeah, that's definitely the right place to start because you really need to understand them before to grasp why AI is such a big deal now. I mean, the whole electronics industry has been facing these huge challenges, right? Product complexity, it's just exploding. Development cycles, shrinking constantly. And then you've got supply chain volatility messing things up, sometimes really late in the game.
Ugh, yeah.
So traditionally, the PCB design flow, it was very sequential, a real bottleneck, super reliant on intense manual work, which, often led to these really frustrating rework loops.
Why doing things over and over?
Exactly. And get this, just the physical layout and routing part, that alone could easily eat up over 30% of the entire project's time and cost.
30%. Wow. It's huge.
It's a massive investment. Yeah. Time and resources.
Okay. So if that's the bottleneck, how does AI come in and re-architect this whole thing? Is it just making steps faster, or is it something, deeper about the design thinking itself?
Oh, it's much deeper, way more profound. AI isn't just about speed ups here and there. It's enabling a process that's more parallel, much more predictive, and ultimately optimized. It does this by adding intelligence at, pretty much every stage. It genuinely re-architects the workflow.
That sounds pretty transformative. And looking at our sources, it seems like the earliest, maybe the biggest impact AI has is this idea of shift left, especially in what's called the pre-layout phase. Could you maybe give an example? Like AI-powered component selection, say, with something like Flux Copilot. How did that change things right at the start?
Absolutely. That's a perfect example. So instead of designers spending ages manually digging through databases.
Which sounds tedious.
It is. Tools like Flux Copilot, they connect directly to real-time supplier data. So you're seeing literally up-to-the-minute info on pricing, stock levels, and this is critical, the component's lifecycle status.
So is this part about to become obsolete?
Exactly. Is it nearing end of life? Are there good alternatives available right now? Having that foresight, it helps you avoid those really costly late-stage redesigns because a part suddenly isn't available or is obsolete. That saves just incredible amounts of time and money later on.
Okay, so that smart selection feeds into the next step, schematic capture, which you mentioned could take weeks before. What's the AI revolution doing there?
It's honestly revolutionary. You have platforms now like CircuitMine, for instance. They can generate fully functional schematics and the bill of materials, the parts list.
The BO.
Right, the BO. They can do that in minutes, starting just from high-level requirements. That process used to take weeks, easily.
Minutes versus weeks. That's huge.
It is. And what's more, you've got other AI tools. Caddy is one example. They can scan schematics and find significant errors in something like over 65% of the designs they check.
Over 65%? Seriously?
Seriously. And catching those errors early is so vital. It prevents this cascade of problems down the line, which gets very expensive to fix.
Right. Prevents the errors from multiplying. So, okay, you've got this intelligent schematic. Now you move to the physical design. And this seems to be where generative AI really shines, transforming placement and routing. We saw some, frankly, staggering numbers on this in the sources.
The numbers are staggering. Let's take component placement. So this task, it might take a skilled designer, say, 3 full days of just manual clicking and dragging.
3 days solid. Okay.
Cadence has a tool, Allegro X AI. It can cut that down to just 75 minutes.
75 minutes from 3 days.
Yep. That's a 97% reduction in time. But crucially, it's not just about speed. It often improves the actual layout quality too. For instance, reducing the total wire length by maybe 14%. That leads to a board that's more efficient, potentially more reliable.
So better and faster.
Okay.
And it doesn't just stop when the layout's done, does it? AI seems to play a big role after that too in post-layout analysis, like predicting problems.
Exactly right. Post-layout, AI brings predictive power. It can, for example, predict potential hotspots on the board areas that might overheat before you even make a physical prototype.
That's useful.
Very. Or it can identify potential signal integrity issues like crosstalk. That's where signals on nearby traces interfere with each other. Finding these things early lets you do many more design iterations digitally, tweaking and improving until you have a much more robust product.
And there's something about manufacturing yields too. DFM.
Yes, AI-powered DFM, Design for Manufacturability. It analyzes the design for potential manufacturing problems. We're seeing it boost first-pass manufacturing yield, meaning the percentage of boards that work correctly the first time from maybe 84% up to around 96%.
That's a significant jump in getting it right first time. It feels like this isn't just about making things efficient, it's really about managing risk, especially like you said in high-stakes areas. The sources mentioned medical devices where failure just isn't an option.
Absolutely critical there. In medical devices, for instance, AI analysis has led to a 25% reduction in signal noise on sensitive PCBs. And here's something really impactful. Some AI systems can predict potential PCB failures with up to 90% accuracy, sometimes even 7 days in advance.
Wow, predict failures before they happen.
Yes, and that capability has led to about a 40% reduction in unexpected device downtime in some cases. That fundamentally changes how you think about reliability for critical tech. So looking at the big picture, think about a medium complexity board. Its layout time might drop from, say, 20 days down to just 2 or 3 days because of AI.
20 days to 2 or 3, that's nearly 90% faster.
Exactly, a nearly 90% reduction. The ROI here isn't just additive, it's multiplicative. It leads to profoundly shorter overall project timelines, getting products to market much, much faster.
Okay, this all sounds amazing. Almost too good to be true in some ways. But like any really powerful new technology, AI must come with its own set of, challenges or things engineers need to watch out for.
That's a very important point. Yes, we definitely need to be realistic about the current limitations. There's the so-called black box problem, for one. Sometimes it's hard to understand why the AI made a specific decision. Its internal logic can be a bit opaque.
Right. You trust the output, but don't fully know how it got there.
Sort of. And then there's the data dependency. AI tools are only ever as good as the data they were trained on. Biased or incomplete data leads to biased or incomplete results, which naturally raises the big question, what does all this mean for the human engineer in the loop?
Yeah, that's the million-dollar question, isn't it? It really sounds like the role is changing, maybe evolving, rather than being replaced outright.
Yeah.
How do you see that human-in-the-loop thing actually working?
Precisely. The key word is augment. AI augments the engineer, it doesn't replace them. The engineer's role, I think, elevates. It becomes more about being a system architect and maybe what you could call an AI shepherd.
An AI shepherd, I like that, guiding the AI.
Exactly. Defining the goals and constraints for the AI, carefully validating its outputs and making those final, crucial strategic decisions. The human is still in charge.
So for you listening, if you're an engineer, your skill set is shifting. It's less about the granular manual tasks.
Right.
And more towards, systems level thinking, understanding the whole picture, and needing deeper multi-physics expertise, knowing how electrical, thermal, mechanical aspects all interact on that board.
Definitely. Plus, a certain level of data science and AI literacy becomes important. You need to understand how the tools work, at least conceptually.
And fundamentally, it's still about strategic problem solving.
Yeah.
Just maybe at a higher level, orchestrating the AI, like you said.
Which brings us to maybe a final provocative thought to leave people with. The real future, the competitive edge, it belongs to those engineers who learn how to architect the problems that only AI is capable of solving, framing the right questions for the AI to tackle.
Architecting the problems, that's a great way to put it. Asking the right questions becomes the key skill.
Well, that's all the time we have today. Until next time on AI for Specialists.